So once again, welcome you all. Thank you.
Thank you much.
Thank you, ma'am.
Now I
Now I
request
request
Mrs. Kusha
to
introduce the
first person to the session.
Good morning, everyone. Myself, Usha Duval, Assistant Professor, Department of Commerce and Business Administration, Sharda University. I am delighted to introduce our research person, Dr. K. Ria Rahman. Dr. K. Ria Rahman is an Assistant Professor of Finance at National Institute for Management Development. His special areas of interest are corporate finance, behavioral finance, and financial analytics. His PhD is on interested defense and behavior and has more than 1 year of experience in academics and industry. He has published research papers in various areas linked to the internationally recognized quality list, such as the Australian Business Review Council, Web of Science, and Status, in addition to acting as a reviewer for the journal listed in the same. Further, his case studies are published by IB Publishing, Sage Publication, MRI. Listed in Harvard Business Publishing and Case Sector among other reputed journals. His case study was chosen by IB Publishing and submitted for the EMMB Global Case Competition 2023. He serves as an editorial board member of reputed journals like Future Nature, Business and Economics. He has conducted various faculty development programs and management development programs in the areas of case writing, research methods, data analysis, and predictive analytics. In addition, he has consultancy experience with government bodies and private companies. Thank you.
Thank you, ma'am.
Thank you, ma'am, for the brief introduction of our research person.
Now I
Now
request
I request
technical
technical session by research person
take over
to take over the session.
Good morning, everyone. Hope I am audible.
Yes. Yes, sir. It's
Yes, sir, that's what he does.
Thanks for that wonderful introduction. So, as the technical session is going to be on predictive analysis, analytics. So, we'll come to that discussion what is analysis and analytics. And its application in finance and commerce. So, before we begin, I thank Sharda, colleague, for giving this wonderful opportunity to share my thoughts on this particular topic. The next two sessions, this entire session for next 2 hours is going to be on what is meant by analytics and why it is called as predictive analytics and what are the methods involved in it in general and how it is applied in the points like finance and commerce management. To begin with, I'll share the PPT and we'll start the session. I hope the PPT is visible. The PPT is visible.
Yes, sir.
Yes, sir, it's visible, sir.
So the session is focusing on predictive analytics and finance and commerce. So when I say analytics, basically we are talking about for better process, I just skip my video. So when we say analytics, we are actually talking about data. So what we do with this particular data and what we infer from this particular data. So the data which is available for us makes us analyze it to get some inference out of the particular available information for a better understanding, for a better usage for commerce, management, finance, and things like that. Primarily, it is called as analysis But when we say analytics, we are actually talking about more intervention of software rather than manual intervention in the particular data set. So that is the reason why the team is, termed as analytics instead of analysis. So when we say it is analytics, we can do that particular process with various methods, but it is broadly classified into two categories called as statistical and machine learning methods. So you can do analytics with statistical methods also, and you can do analytics with machine learning methods also. So this we need to be precisely keeping in mind when we are talking about analytics. See, in the inaugural session itself, the chief guest, Vishnu Kaka, has spoken about things like the tools remains the same, but how this applied in what context, what scenario, how interpret basically changed actually. Today the scenario is same, whether you choose a traditional chi-square, pre-test or conventional methods like ANOVA, or whether you are using machine learning models with different capabilities and different functionalities. The purpose of using those techniques remains the same. You use the data and then you infer from that particular. So technically speaking, data scientists, as they call, they are basically conventional statisticians upgraded with computer-based techniques or computing power, we can say. So this makes us to understand analytics is not just computer-based or computer-driven machine learning models, but the statistical techniques equally have importance in analytics scenario. So we need to understand like what is the basic difference between the statistical methods and analytical methods, and then we are going to before that different understanding the difference of statistics and machine learning. We are going to actually start with what are the types of analytics that is available, not only in finance, and the topic we are discussing today is on finance commerce. It is applicable to all the commerce and insurance. So we will discuss about the types of analytics and we will move on to what is the basic difference between statistics and machine learning models, on what precisely machine learning models is all about. And then I'll take you to different applications of this analytics in the field of finance and commerce. And then we will take one case scenario, in the sense like use case, how it is used in stock trading or credit risk analysis and banking like that. So based on the time availability, I will be demonstrating to you how the analytics basically works in these two dimensions based on the using the Mars software course very quickly on the particular. So when we say types of analytics, there are basically four types which are available. You can see on the screen there are descriptive models, diagnostic analytics, predictive analytics, and prescriptive analytics are there. So the graph shows in terms of complexity and in terms of valuation, we have all these analytics placed in the different positions. Further, you can see the two sets of analytics are basically focusing on past information, emphasis on past information, wherein the other two sets of analytics are emphasizing more on future information. Of course, in terms of value and in terms of complexity, both are in different places basically. So this descriptive and diagnostic skills are less complex, and in terms of value addition to commerce and business and finance, it is comparatively lesser than the other program. Whereas the predictive and prescriptive has a lot of complexity, but the value which is added by these analytics to the
Sorry, that slide is not moving, sir.
Now you can see that, right?
Yes, sir, for example, what are you saying?
Okay, fine. So we're going to share the screen. So I hope now this is right. So in terms of complexity, as I was mentioning, you have highly complex predictive and prescriptive analytics, where on the other side you have descriptive and diagnostics, which is less complex but less value. Right. So our emphasis is more on predictive analytics today, because this has a lot of methods which we need to understand, like how this is being applied in business. Of course, when we are talking about business application, obviously in business research also we will be applying the same kind of methods in order to understand the data and add value to this business. But before going to the predictive analytics, I will quickly take you through what is descriptive and why it is called as descriptive, and what is diagnostic and why it is called so. And same way, predictive and prescriptive. Descriptive is more of describing the data. So this is basically about summarizing the findings and understand what is going on in business. For example, you have softwares like Power BI, RAM, View, and all, which is more focused on summarizing the data on a real-time basis. So this is what you mean by descriptive analytics. Take data from different places and you try to aggregate it and summarize to get insights for managing your business. So majority of the analytics which are used today, not only in finance, in commerce and business domain, are basically descriptive analytics, because the complexity is simple and of course the valuation is lesser. But most of the people uses this particular analysis. So when we say diagnostic, it further intertwines the descriptive process, and then it says like why something has happened in the past. It may be a simple, correlation analysis between two factors. It can be X and Y, or Y got impacted by any. It can be a advertisement, and it can be sales, or it can be what you call employee training and employee retention. Or in the financial context, any interest rate changes that happen and how many people have defaulted. So it precisely works on data discovery, mining, and more. Most importantly, it talks about correlations between two different factors which are not, which are directly or indirectly connected. So such kind of analytics are called as diagnostic analytics. But in terms of theory, descriptive analytics has a lot of information. Diagnostic is an advancement to descriptive, but how much information or theoretical fact of this particular process has a problem. This is about descriptive and diagnostic. Now coming to our topic of discussion, predictive. So we know predictive is all about predicting future outcomes. So you will try to find out something. Let us say it is why. This can be anything you want to find out what is your income or profit or what is your sales in the business, or it can be any changes that you are trying to find out for a particular business process. So the essence of predictive analytics is to devise models. This is what broadly analytics in the broader sense, AI also called model building process. So if with the existing data, we try to extrapolate the future occurrence. How accurately we are creating that particular model is that much of value that we are adding to the business. So this is where all data scientists work in terms of increasing the accuracy of the predictive models. The methodology remains same and the process remains same, but it is like objective of this data scientist. Using this predictive analytics for finding out the future outcomes. Future outcomes doesn't mean what will happen in the next year. When we are using, let us say, Ola, Uber, or Zomato like that. So, in which area, geographical area, you will be having most number of orders coming in during this particular day and this particular time, let us say, 11:20 p.m. This is again a predictive model. This model predicts on a real-time basis based on whatever information we have. In the sense, these apps already has their database. So the entire business activity primarily depends on the data analysis, and depends on that they'll be showing the restaurant, showing the vehicle, and they'll be they're programmed in such a way the prices are fixed like that, or the discounts and offers are fixed like that. So predictive analytics is everywhere around us, whether we understand how that it works or whether we don't have any idea about it, we are already in this process. You search at YouTube, if you open a YouTube, it will prescribe what will be your favorite videos to watch. That is again a predictive analytics. Based on your past search and your metadata that they have on the regional and other aspects, it will be suggesting that this is a trending thing, maybe. So why am I describing it in different dimensions and socializations here is basically at the end, if you are in finance or if you are in marketing or if you are in HR or generally all the business or commerce or production, we narrow down to that particular thing that is called as data. And this data is actually being used for predicting what will happen next, which adds value to the business. Right? So this is about predictive analytics, as I was mentioning in the initial discussion itself. It majorly relies on machine learning algorithms and also statistical methods in order to learn from the existing data and also test. The models are basically tested on the available data before it is deployed for real time. Only after native it will be applied in the business context. So far we have discussed about what is analytics and different types of analytics. Now the last one, so very quick. Prescriptive is predictive talks about with the what will happen to this variable. Can be any variable. Number of orders for a restaurant or number of food trips for a customer, of a customer for a retail mall or retail shop. It can be anything. So this is actually extrapolated for a future time period. Whereas prescriptive is, in case if Y moves like this, what should we be doing or what should be other factors, let us say how you check the let us say X1, X2, or the other dimensions of your maybe Y1, Y2. So this process is what is called as prescriptive analytics. And it is in general the methods involved is basically optimization and simulation. So optimization is basically a mathematical process. Wherein simulation is again the same thing. But the basic idea about simulation is like you'll be given different scenarios and you'll be given the different outcomes, basically n number of scenarios and n number of outcomes. So based on the different outcomes, you'll be prepared with different decisions basically. You may be an investor, want to understand how the stock price moves, and then you simulate and find out different stock prices basically, and you find like after all the simulations, you have the lower end price, let us say, it is like 1,500, the upper end price is basically 3,000 like that. Now the stock is actually trading on 1,700 rupees means we can take a call like in case if it is goes to 1,500, what I should be doing. In case if it is increasing to 3,000 level, how should be I should be capitalizing that particular utilizing that particular scenario. So perspective is more about generation of different scenarios and simulations of optimization techniques that helps the business, come out with the very accurate decision making for the future. But again, as similar to diagnostic, prescriptive does not have much theoretical background. We have very few methods involved in it as a theory. Maybe in future this may evolve. But as of now, when we say analytics, we are actually talking about predictive analytics. Majority of the model are predictive analytics. Descriptive is still analytics, but it is basically presentation of the data and aggregated summary of the data. It is not about what happens in the future and based on the nature decision. So this is about the type of analytics. I will now I will get into what do you mean by this predictive analytics and what are all methods involved in this predictive. So we have discussed what is analysis and what is analytics, and we have moved on to different types of analytics. And we have seen like predictive analytics is a major method involved in almost all the processes. Okay, we are not touched upon the concept of AI as of now. Of course, in the process, I just tell you why it is called as AI and what the GPT things about that. This not entirely different thing, but it has a different workflow and different methodological applications. This predictive analytics is basically as I said, you try to predict the future outcome. Now, that is not the one key aspect which is involved. There are other layers of this prediction. It can be entire prediction, or it can be segmenting, or it can be association, or it can be a forecasting. So what do you mean by prediction? What do you mean by segmentation? What do you mean by association? We're not going to discuss in detail about these methods, why I understand there are different methods. These are not limited. Every day methods are evolving and evolving. But this is the broad classification. There are four aspects involved in the predictive analysis. When we say prediction, we have already discussed, right? You will have a Y variable, and there will be an experience of X variable or the n number of X variable. So you predict the Y variable of the X information. Something similar is what is called as forecast. The only thing we need to keep in mind is like there will be Y here, and there won't be any X. You have the same Y detail, the previous Y detail. Last year, data are today's calendar, day before yesterday's calendar, or sales, last quarter sales, previous quarter, previous quarter. So if you predict the Y based on the Y information itself, it's called a forecast. But predict the Y based on the other X, let us say advertising, celebrity endorsement, things like that on the sales, or it has prediction. Or if you are predicting share prices based on GDP, based on inflation data, things like that, or companies' earnings per share, things like that, then it is called as prediction. These two look similar. The other two are easy to identify. Segmentation is a process of you give a data to the model, and there are different information is available. Let us say like customer information is available. Right? you try to, if you want to get more information out of this particular table, this is a process called segmentation. And the segmentation will say like these people belong to one category, and this people belong to one category, another category. After that, you will be able to find out like what is how we are going to treat these particular people different, what basic characteristics difference are, and how we learn. So this is again a very important contribution from predictive. Then association is very easy to identify. Association is all about, of course, you will have variables, X, Y, X, or things like that. And it is not about what is dependent on the other, it is about both are dependent. If you want to look into such kind of analysis, go for association aspects. So we all know about statistical methods like correlation is different and regression is different. Regression will have a dependent variable, whereas correlation will have no dependence. So such process is what you call it as association process. Now you can notice from the slide, there are different methods available. And they are colored differently. Right? So these methods which are mentioned in green are basically statistical methods. So regression, multiple discriminant analysis are all statistical methods. For prediction purpose, for segmentation purpose, you have cluster analysis, the set of models which are available, and for association we have correlation. And for forecasting, we have ARIMA model, GOR model. These are time series. So, in the later part of the session, we'll be touching upon this particular area. So, these are statistical methods. And the things which are mentioned in blue are basically machine learning models, which does the same process. So, there's neural networks, support examinations, k-nearest neighbor machine learning. This permanent networks. So, DB scan and how machine learning models. Again, the same way LSTM neural network machine learning model, which does the same process of forecasting, prediction. Now, there are some intermediate methods available which combines statistical methods along with some mathematical, what do you call upgradation or optimization. So with those techniques, they are called as rule-based methods, or it is in between these two models, statistical models and machine learning. It will take some aspects of the statistical models, some aspects of machine learning models. Such not purely called as machine learning or not purely called as statistical, it is in between. So they are called as rule-based mechanisms. But for all practical purposes, they are called as predictive models. So these rule-based models are not very broadly defined as equal to statistical machine. So, but technically it is not neither statistical nor entirely machine learning. So here it is classified as a rule based. So in basically an operational aspect, they are called as machine learning models. Now this is about predictive analytics, the methods involved, and what about we can do for a particular predictive analytics. So we have discussed about what is analytics and what are the different types of analytics and what you mean by predictive analytics and what are the methods involved. Where you have, and I'm just bringing that layer along with the discussion. When we say analytics, we are not actually mentioning it is totally machine learning. Statistical models also can be used in this purpose of predictive analytics. So you can, it is up to the developer or the company to decide on what is analytics, what is the contribution or what is the accuracy of the statistical model and what is the accuracy of machine learning. Now, taking the research dimension into consideration, if you are doing a research in the particular area of commerce, business, finance, marketing, like that, you will be having a data. So obviously, we have to find out like which type of what is the purpose. Obviously, if it is a predictive purpose, we for checking like which model is basically more beneficial. We should not be stopping at regression analysis alone. We should go and try out the neural networks, support vector missions, ADRS frameworks, frameworks, decision trees. Why? Because both these models coexist in a scenario right now, because both has its own advantage. I would not say there are some limitations in both the models. But what is important is both the models exist because of their advantages. Now we are going to discuss like what do you mean by statistical model and machine learning model and its similarity and how it differs basically. And depends upon your research objective and depends upon your when I say company's requirement, we are actually talking about applied research. Okay, base research or basic research talks about your theory building activity. Applied research talks about how to build solutions for companies' problem. So most of our research either fall into this category or it will be in the mid of these two dimensions basically. So without company's requirement, you may be doing a research which will solve overall the company's problem, overall problem like that. This simple prediction of sales, simple prediction of the customers interested in the product or interest or service. When you are using a bank facility, obviously you get a call. It is not a random call. You can find out like you would have done some activity with respect to the particular mistake, and you will get a postcode loan or you will get a credit card and things like that. So for banks or for companies, instead of targeting random numbers, they will sort it out and find out like these people will be the probable need of this particular. So here the Y variable or the predictor variable is the requirement of a particular person. When I say requirement, you might think like how my requirement is known to another person. That is where the beauty of statistics comes. We use proxies basically. Proxies in the sense, I just give a simple example. You have a bank account and your average balance is basically 10,000 throughout the years that you have kept this particular, let us say 5 years. Now all of a sudden, your bank account remains without minimum balance and it goes zero and there is a automatic clearings, vouchers and you are charged with negative risk. These are all abnormalities that they can easily find out from a particular set of data. So you have a very clear data for 4 years with average balance maintenance like that. The last 1 year or last few months, you have a lot of fluctuations like that can be easily found out like out of it balance. If a particular account is having very high deviations in the recent time consistently for 3 months, obviously there might be some financial problems that the person may be facing. So this kind of accounts can be summarized and filtered, and that customers can be targeted. So that the probability of converting these customers would be very, very easy for the bank. So I have just given one type of example. Similarly, it can be any Y and any proxy variables can be created to predict something that would help your business or commerce. Now, I'll just quickly take you to the technical differences between, first similarities between both machine learning and the statistical model. So both requires models for prediction that we have already discussed. Both approaches call for certain level of domain knowledge. I was just mentioning about banking data with my basic understanding of how banking operates. Likewise, you can have domain data in order to create models of it. So both methods rely on algorithms. Okay. Algorithms is different. YAML methods are different. Algorithms is basically talks about the coding aspect involved in the particular process. You can code using the normal statistical regression model or normal distributed analysis model, or you can code with the sophisticated neural network and kind of ML methods. So for both the things, we need coding kind of aspects. So careful evaluation of data-related aspects like outliers, missing data, which we conventionally do with the data, is also required for both the models. All these are basic similarities. So before, as I mentioned previously, before you deploy a model, you need to validate the model with the test data and then evaluate this accuracy. Then you can go for applying the particular model. So these are all similarities for both statistical and machine learning. So what are the differences? In statistics, the relationship between variables is found in the form of mathematical equations. In ML, the relationship between variables is formed by the self-learning algorithms. As of now, we'll just keep this particular dimension here. Equations we are aware of, like y is equal to a plus bx, is an equation, the regression model. You can easily interpret as a relationship of how far the axis increase of y is dependent on this coefficient, right? Now, self-learning algorithms is what do you mean by the architecture? The architecture, this is a ML architecture. The architecture is totally different, like how the conventional mathematical model. So this is a very wide difference. This will be discussed shortly. The purpose of statistical model is to find the relationship between variables and to test hypotheses. This is very important. Whereas machine learning is all about prediction. So with this example, I mean with this equation, because I can tell you, you have the y, which is a predicted variable, it's a dependent variable, and you have the x, which is a predicted variable. Statistical models primarily depends on how much this x is impacting the y. So it is emphasizing more on this beta value. The statistics wants to know the level of impact we see. Where in machine learning, this level of impact is not found out. The emphasis is on how accurately this text can predict the wide thing. I hope you are understanding. So technically, in machine learning, you will not have any coefficient basically. This beta, alpha, for example, 0.5% of x impacts y kind of interpretable information are very, very less, and that's why these are called as black box models. So that is about the relationship between variables and technically hypothesis. Hypothesis testing is particularly specific to statistical model. Because you can extrapolate and do that with the machine learning model, but the very essence of statistical models is hypothesis. So to put it simple, hypothesis testing is all about you take a sample information and you find out like how far this sample fits the population information. So this process is what is called hypothesis testing. So we have the p-value and things like that. I don't want to get into that because it needs a different flow of discussion basically. So basically the p-value talks about in case if you repeat the same testing x and y, what is the probability of the results being wrong if you are using a different sample? In case if the result probability of results wrong results are lesser than 5%, you will come to a conclusion that x has this much amount of impact in y even out of the sample, which is the population. It was a bit technical. I'm just explaining it because we cannot interpret this kind of information in a machine learning model because machine learning is not meant for interpretation. It is meant for prediction. You will have x and you will have to find out what would be the y. That is the ultimate purpose of machine learning models. So in order to do this sample population, p-value and all, we have a lot of assumptions, normality and things like that. Where in machine learning you rely on such kind of. So probably as of now you have found the basic difference between these two because of that, what will happen to the real-time scenario? Right? In a real-time scenario, you will not be having data which meets your statistical assumptions. For example, this normality and things and all, you will not be able to get in the real time. The real time data will be very, what do you call, unstructured, or it is totally different. It will not fall into this normalization category most of the time. Right? So that is the challenge in the real time scenario using statistics. It doesn't mean that you cannot use statistics. You can still use, but the level of prediction power is very, very lesser. It will not be that great. So you won't have accurate prediction. That is predicting. So that is the limitation of statistics. So which is basically taken care by machine learning. So machine learning models. There are two things. One is big data and statistical properties. Statistical properties, all these assumptions that we say. Statistical assumptions. So when it is big data, statistics will not help. Because when the large number of information, the informations are increasing, that statistics tend to go favorable results. Wherein machine learning can be used for that particular process. So when it loses its capacity, it will go for machine learning, particularly in big data. Similarly, when statistical assumptions need to be made, obviously people will go for statistical interpretation, statistical model. They will not go for machine learning. These aspects are basic difference between statistics and machine learning. Today we have huge data coming in because of data, information technology, app availability. We have chip manufacturing company coming with huge trillions of data storage capacity about NVIDIA, things like that. So that brings us a lot of data and handling capacity, so people are more towards machine learning language. But still, it is not like all the data are large data or big data. So you will be having some company specific information which may be 1,000, 2,000, 3,000, 10,000 information. So that will not require a machine learning model, because if you apply ML on a small data, it will get to be inaccurate. The nature of statistics is small, the nature of machine learning is big. So when the data is like that, we will apply such a fashion. So statistical models are interpretable. As I said, ML models are less interpretable. Not interpretable. Today people are coming with interpretable ML methods. So things are evolving in that direction. Statistics not well suited for large amounts. So this is the basic difference between statistics and machine learning models. So far we have discussed about analytics, and then types of analytics, and then we have discussed about predictive specifically, then what are its applications basically, and then what is the basic difference. You can do this predictive analytics using statistical and machine learning methods, and we have discussed the difference and similarities between statistics and machine learning. In case if you have any questions in time, you can just post in the chat box. Specifically, I will try to answer in the flow of the discussion itself. Right. So I just now take you through a particular process called machine learning architecture. There are a lot of aspects involved in it. What I'm trying to do is like I'm trying to bring in everything in a more precise way so that it can be summarized and you will be able to understand broadly what is predictive analysis, deployed in commerce and finance. So I'm not using the word research often. So when I say business, commerce, and finance, management like that, obviously as a researcher we need to, we are actually focusing on the real-time data and we are trying to find out a solution for a real-time problem with our research objectives. So for any type of research, if you have a requirement of prediction and if you have a data structure like that and if you want to focus more on the prediction accuracy, go for an ML model. If you want more interpretability, you want to find out the impact of one particular variable on others, and we want to find out like how to improve that X variable so that your Y variable is better at comparison. Sometimes there are a lot of research papers comes in with the application of both statistical models and ML models. So they are trying to compare like in a particular context. What is the basic difference between the accuracy of the particular model? So we can go ahead in such a way also where we apply ML models as well as statistical models in order to predict something and then find out how accurate the prediction is. So I'll quickly take you through a ML architecture. I'm not using this name ML methods. Whatever we have discussed so far are ML methods. Methods are basically KNN is there and LSTM, long short-term memory. This is used for stock prediction like that. When I say architecture, we are actually focusing on, like in statistics, we have mathematical models, right? X, Y is a function of X, like that, right? And then you will say algebraic model, lot of other models are there. So all of the statistical models are built on this kind of understanding. But when it comes to ML architecture, this neural network is the foundational architecture behind all the other statistical models. So even we are using today something like GPT is called as generative pre-trained transformer. This transformer. Transformers are advanced. This is a very highly advanced version of basic artificial neural network. So again, when I talk about AI is an extension of analytics work. So you will have two types of AI. One is predictive AI, and one is generative AI. So this GPT is basically a generative AI. Our focus is more on predictive analytics. In fact, all these particular processes, whatever we have discussed so far, also as a predictive AI process. Because AI has some more additional dimensions, but the basic analytics works behind the AI is predictive analytics. Whatever we have discussed. Now coming to the ML architecture. Artificial neural networks, as the name refers to, it is basically inspired by the human neural network. How a human neuron works. So based on that functionality, this machine learning algorithm has been designed as an artificial process. A typical neural network will look like this. I just explained what it is and how the process works. We have three layers. One is input layer, another one is output layer. In between, we have hidden layer. I don't want to get into more, specific aspects of what is feed-forward, what is backpropagation, and things like that. The GPT we have discussed is the backpropagation model, and it uses feed-forward model. There are lots of models, different high-level methods are available. Now, I'll just explain how this works. Here, in a statistical model, y comes on the left, and you will have x on the right side. In the machine learning model, these are basically x, x1, x2, x. And you have y here, not necessarily y, it can be y1, y2, y3. So this hidden layer is what actually does this learning process. So it will quickly find out with the values of x1, x2, x3, x4 like that, and find out the values of how y affects the y1, y2, y3. Without any statistical properties, it will quickly go through this particular process and find out like, okay, this this X has this relation to Y. This X2 has this relation to Y. So this X1 is related to Y1, Y2, Y3, Y2 till Yn. This X2 is related to Y1, Y2, Y3, Y4, Y. Likewise, lot of X's will be there, lot of Y's will be there. It cannot be interpretable basically. Because let us say like if you have some 5 variables and if you have 8 hidden, 5 hidden layers and then you have some 5 output layers, so this would be the combination of information. Technically, this model is actually a toy AI model. Toy AI in the sense, this is like ABCD in English letters, sorry, English language, like a letter in an English language. So likewise, today's AI models or ML models are evolved to greater extent, and today we have GPT 4.0 that comes with huge amount of sophistication. So why I showed you here, instead of going gray on this particular dimension of what is ML and what is predictive analytics, this basic understanding is sufficient. So this is what you call it as basic artificial neural network, which works on, and bring this information for numbers so far. This ANN was developed on numbers, but quickly there are other this thing called as convolutional neural network, and from there recurrent neural networks. Convolutional neural networks used to accept unstructured, non-numeric data like images, text, and speech, like convolutional and recursive neural network. Convolutional is for unstructured and RNN for non-numeric data. Unstructured in the sense, so far here it is unstructured, in the sense when you are classifying X1, X2, X3, and if you are giving the information, we are actually structuring this information. So normally your ANN focused on structured information, and we were talking about segmentation. So that is totally unstructured. The purpose of that analysis itself is to structure the data, segment the data. So these are unstructured information. The majority of the real-time information are unstructured. So the convolutional neural network has taken. And we have non-numeric data, images, text, speech, and all these are taken. Different neural networks. So this was just to give you a perspective of how things have evolved in different platforms. We have discussed these things. So these nodes, interconnected nodes, is what we call it as neurons. And there are 3 layers, as I have already mentioned: input layer, hidden layer, and output layer. Right. So hidden layer not necessary to be 1; it can be any number. So there is no consensus in the among the computer scientists or ML data science people. How many networks are good actually? So they say lesser networks is inefficient. Higher networks, if you instead of 2, if you are going for 12, 30, like that, it will be giving some inaccurate or biased information because of its overlearning. It will become over smart and it will try to say something else which is not real. So there is no consistency in the number of neural networks. It depends upon the data, depends upon the they try to find out like how many number of layers of what they are. So this is about architectures of ML. So as I already mentioned, the interpretation as a mathematical function is really hard in ML. You can see here it's all vague, it's not exponential. So you cannot easily find out like what impact is actually creating. So that is why ML algorithms are called as black box method. You cannot interpret this. Right? So I think here I'll stop with this particular ML methods. I just quickly move on, like why did we have mentioned artificial intelligence? This is nothing but outer layer of analytics. So you have something called as deep learning, and you have something called as machine learning, and then you have something called as analytics. Total it is called. and the overall layout is called as AI. Of course, it has a lot of other inputs coming into the picture, but this is the layer based. So that's why we can easily call this predictive analytics as predictive AI, because prediction is more or less precisely the analytics process in the AI process. Okay. So you don't have to worry actually. AI is nothing but a sequence of codes which are basically runs into thousands and millions of information. These are basically called as foundation models. These foundation models are created by, let us say, Google Data, OpenAI, they come up with GPT, and Sora, things like that. So those are product based foundation models are this GPT foundation models. ChatGPT is a product. So with these foundation models, we can actually use this models in order to solve our purpose. That is what all the companies are doing today. So whatever we have discussed are foundational aspects involved in this ML-based methods, solving and predictive analytics aspects. Now I will take directly to the application aspects of predictive AI, not only components, we can call it as and things like that. Okay. As I said, it can be predictive analytics also. So I have brought this terminology here just to make you understand like both are not so different. But sometimes analytics are called a subset of AI and sometimes AI is called a subset of analytics. So they both use statistical algorithms to forecast trends, be able to pattern and prediction from large data sources. This is by definition AI. When we say AI, we actually large data. You don't have a database and then run an AI. The sense like the learning aspect is not possible with the small data sources. So that's why AI is nature itself. It needs a lot more data. So where all it is applicable. You can see there is a professional services. Ernst & Young has saved 250,000 hours of manual labor by integrating intelligent document automation in the form of credit. So document automation, I can explain how it works, but basically focusing on the time aspect, I'm just giving you directly the example. For example, in food and beverages industry, PepsiCo is using predictive AI for inventory management. So you can understand these things as data and what can be interpreted and what can be predicted. So that is what exactly happens. Here in travel, this company has, Nagios company has to process 1 lakh transactions per second to reduce data fragmentation across travel stakeholders. And this is one of this. I have a there's a technical. Sorry for that. There is some other aspects of that. Fine. So this is about how different the companies are using this particular predictive AI process. Travel company. I'm not getting into the details of what data they will take, how they will use like that. Quickly, healthcare companies using it to find out like which place is more optimal location for clinical trials. So it is at the end everything is data and what you try to predict or what you try to segment is what matters for the analysis purpose. You can use a particular model. So e-commerce company does a cognitive research kind of behavioral research to find out like what is the highly relevant catalog scores that's going to business processes. So that is for example Netflix, Amazon, even Zomato or things like that uses this kind of. So, coming to the financial dimension of how where this predictive analytics is being applied. So, we can generally call, of course, all our ML is ML models, but we can get into the common AI. We can further classify this into natural language processing, which basically works on text data, and they'll do something with respect to the behavioral aspects of this called as cognitive algorithm trading, and this machine learning and other aspects which are done in terms of numbers and machine learning. There is no much theoretical difference in these aspects. All are machine learning models which are basically working on numbers, text, and then images, videos, voice, whatever the input it will process, it will predict and send the output. So this is how it works. Particularly to finance space this thing, to robo advising. If you have some stock accounts or if you have a bank account, it will say any investment account, it will say like you prescribe it. This is not an optimum this thing. So you will be you will have to increase your holding in stocks or holding your deposits or cash. So that is called the robo advising. Customer recommendations. Right, obviously we get a lot of messages from this thing. You are having pre-sanctioned loans or personal loans like that. You have pre-sanctioned credit cards, or you can top up your you have an approved top-up limit in your credit card, things like that. So all these are basically recommendations which again works on the same ML models in order to predict something and offer to the business basis. You would have seen heard about or read about fraud detection. Right? This is what is called as AML's anti-money laundering. For a simple thing, let us say you get a notification like when you are using your credit card in a different geographical location. You get a message automatically comes from the credit card company saying like your credit card with this number is used in this location. So given this call if it is not you. Which means like it's a pre-set program in such a way that they are finding out like this card number is used in this particular geographical location. All of a sudden, if this card is used in this totally a different location with the maximum amount of distance that they have kept, obviously that is an indication that ML models will find out and it will be programmed in such a way that it engages the customer. So this is one way of fraud detection. Anti-money laundering is similar thing. It's about how much money you are actually using in your bank account and how much your average transaction is. So if that exceeds your pay rates, exceeds the pay rates, then it will be finding out like this looks suspicious. This is your own transaction. So what I am trying to say is that there are different ways of applying the same models. So when we understand the models, underlying models, it will be easy for us to deploy the context of our decisions. So you will be having marketing related query or research, you will be having HR related research, or it can be operational production research, finance. Objective data and all same, whereas the deployment is different. Here we are just talking about financial data. Maybe marketing, I will be customer segmentation, geographical. Marketing aspect, digital marketing campaign, projection, things like that. So it all depends on as we extrapolate the methods for different applications. So one of the prominent application is algorithm trading, which I am trying to explain to you with the help of data and with the help of a model. So far we are actually talking about the outer layer of what is conceptually predictive analytics is, what are the types of methods, what is basically an ML architecture, how it is different from traditional statistical models. So you have understood, in the sense that you have by now got an idea about the overall framework of what could be the predictive analytics. So there are different use cases available in different fields like commerce, finance, other business fields like that. So when I take you to a particular process, you will be able to understand the complexity of this particular process as well the workflow, So you can, for example, I'm doing it for trading purpose. You will have a share price data. The same process can be applied for sales data because both are same type of data, which I will explain sooner. Okay, so I will take you to this algorithm trading process. In the process, I explain to you right, how this algorithm, this is a methodology, how this ML models are basically or analytics models are basically to solve the requirement of predicting chart prices. So algorithm trading is otherwise called as algo trading, systematic approach in financial markets to predict the future prices based on the set of rules and processes. So there's a lot of ways. Maybe today you would have a lot of algo trading apps available in Indian context. But they have in the foreign market, they have started in 1980 itself in terms of how it is, when it is applied. But it is gaining popularity today because of more people involved in the stock markets and more people are regularly. So it has started in US equity trading and according to projection in the worldwide algorithm trading industry is anticipated to grow the rate of 8.53% over the next 5 years. Is on up by now because of both COVID scenarios and things like that. So from a technological standpoint, the world has become unrecognizable over the past 2 years. It means if something happens in the US, it affects Indian markets. If something happens in foreign, it affects the Indian market. So just giving a brief of contextual algorithm trading and how it is evolved over a period of time. Again, it is not the algorithm trading evolving, it is actually the base foundational methodologies that evolved the period over the period. That is the reason why application of those ML models in the stock trading aspect also evolved. So today we have something called as high frequency trading. We have come across stock market happening, there's something called as high frequency trading. So within milliseconds, the gains happen. So these aspects are basically a functionality of algo trading. But algo trading by definition is more advanced than these high frequency trading. In the sense, like as a methodology, has evolved as algo trading. Like that. So this electronic communication networks and all like from the floor trading, we have moved on to what do you call the stock trading to electronic media. So it has evolved to a greater extent because 2010 itself and algo trading came into picture. Today we have lost, we are actually 14 years later than that. So there will be a lot of developments in this particular area. But in Indian context, it has evolved in the recent years. So there are plus and minuses, all these are theoretical based. There are little or no human involved in our government. There is constant work being required. Even without any humans, there are very great chances like it will go wrong also. Because, for instance, COVID is a new scenario to the entire world. So if you have created an algorithm that it is operating in all of our COVID happens in the world, and then market reacts to it, algorithm have no idea about what is happening. So it will be operating on a very wrong projection, and we will lose huge amount of money within a fraction of seconds. That risk is always there in algorithm. So I'll quickly tell you, it works on something called as back testing, which means like you create a model and it will be tested on the past data. Only then it will be used the particular scenario. So that is also possible because it is not like blindly you are creating, you are projecting something out of protecting the analysis. You are creating a model with utmost proof. So eliminate emotions. So whether it is done by A, B, or C, all will have the same predictions. So less transaction cost and faster execution, all these are advantages. Disadvantages, as I said, it requires constant monitoring because undefined or undefined scenarios will not be shown in the particular algorithm. So more susceptible to the cyber attacks, all these digital problems are there, high cost of development, loss of liquidity structure. Within fraction of time, you will be looking at the amount of money. So without you identified something that it has happened in the past, something like flash crash. Within 15 minutes of time, the Dow Jones lost huge amount of liquidity because of another event. Before they realize and identify the correct or stop the particular level, the damage has happened. Today the environment is so powerful and the damage is also so powerful. That's why you cannot rely entirely on AI to do everything on an automated basis. I'm just telling an example from the context of algorithm trading companies, such AI-driven processes. Now, algorithm trading is a new topic, in a sense like new, relatively new topic. But what it was previously was in the statistical, I would say like algorithm trading is more of an ML activity. Wherein this was done as a time series forecasting, time series analysis, traditional statistical method. So both are applied in the forecasting of share prices. So I just try to take you to the predictive analytics process in the stock price this thing. But before that, I just show you like how for example the sales information or more precisely a passenger information. This data set is already available in the market. I just going to use it like how it is going done with the time series forecasting method basically. So whether it is a passenger data, customer data, or sales data, or share price data, everything looks like same. All these are time series data. So we are having one by different time periods. For a month, means you have, let us say, 30 data points. For a year, means you have 365 data points. So with these data points, how we are going to present what is the 366 data points. So with this year's information, we want to find out what will happen next year, first sales data, first quarter, first month sales data, first quarterly sales data, first day sales data, share price data. So you try to find out like what happens to let us say what happens to 2 because of 1, what happens to 3 because of 2, likewise the special group. So it is like not only what happens to 1 because of 2, it is like how 3 impacts 1 and how 4 impacts 1. It has to be reversed actually. So how the 4th day information is impacted by the previous day, should be writing in the reverse action. Second day and the first day information. So if you have the sales data today, how yesterday's data, day before yesterday's data, before the day data, today's sales figure is what time series analysis for. You can go on to any number basically, but technically most of that is key term. I mean the time minus 4 is usually be the time of this time series. So this is a broad idea about how time series works. Forecasting is, of course, if a particular time series forecasting, there are different ways of forecasting actually. There are quantitative forecasting or qualitative forecasting. Quantitative forecasting talks about extrapolation. As I said, the method is called time series. So you predict the relationship between different time periods until you find out what the next time period is. Extrapolation. Wherein the other method is called econometric. You will ask me to study about panel data. So those are called as partial method. The description is simple. When you have only y, you are doing extrapolation. If you have x also, find out how it impacts y. So you are basically finding out the partial methods where how x is passed. Some changes in y method, likewise x1, x2. So this is basically called as econometric method or cash partial method. So this is the traditional methods involved in space. In qualitative, there is no methods basically. These are all qualitative methods. In qualitative, there is no precisely the methods involved. Methods in the sense, expert opinions, experts, field experts, observation. They have got out of the experience that they have. All these are qualitative observations. But more accurate, this thing is quantitative. Is there any questions? Whatever we have discussed so far from the participants.
Hello, sir. Most of your students are using structural equation model. How this method is different from structural model?
Okay, you wanted to know how the cell model is different from which model? Time series model.
Model.
AI model. I mean, there was some echo, but what I have understood is like how the same model is different from this AI model. Again, structured equation model is basically a statistical process which how variables are interrelated. Like it is more of a correlation analysis. So we are trying to find out like how different variables are interconnected and how it impacts on target variable. Again, broad classification is a statistical model. You will need to find out the normalization properties and other aspects of the world. Whereas in ML, you don't need such kind of scenario. So it is basically trying to find out like with all these X numbers, what would be the Y. So in SEM, you will find out like weights or factor weights or coefficient weights, like X is impacting Y this much and Y is mediating, X1 is impacting X2 like this, X2 is impacting Y like this, so X2 is mediating to this level like this. So such kind of coefficients or effects cannot be found out in AI or ML models. But unless your objective is about finding out the relationship, you can, if your objective is not about finding out the relationship, you can go for ML and AI model. Because in business, rather than finding out what is the impact of one or the other, people want to be more accurate in prediction. They don't want the relationship, they want solutions, they don't want theoretical explanation of why it is happening. They want, in case if this happens, what I should be taking care of, how quickly I should take care of, how much I need to react so that this here advantage for them. So the emphasis is broadly on this. So statistics are interpretable. Some SEM is a statistical method, whereas ML is non-statistical machine learning. So it will not be the effects. So I think we have started. Until when we can take the session? So I think till 1 o'clock. Shall I continue or complete it?
Yes, you can continue.
Yeah. So because I have not noted, like 25. So I just take you to the next topic of discussion. I'll just demonstrate how things happen with the help of data. Because when we discuss without data, it will be more like abstract study. I just show you how it works with the help of R, with the data using the R program. So R programming is a software which is open source software like you have data analysis purpose. Python is more of front end and it has its own advantage to be used by even front end people. Wherein R is totally data scientist, data analyst. So, if you are a data analyst or if you are a researcher, researchers are looking for the data analysis. It is not a GUI based thing, it's a programming based thing. So, there is a data named air passengers which is available. So our interface will look like this. Particularly, this is a R cloud actually. Whatever instead of putting this R in the system, I'm opening it in the cloud. So this like account we have, wherever we want to know this app of it, so we can use this particular. So this is basically where we can type script and we can run it here. It will be run in this particular console, R console. Our console like this. Here you will be getting there will be four set of statements. If you are new or I don't know, just show you. There will be four fields. This one file information, environment. Our environment will be here, and our graphs, visuals, and outputs will come in this particular data. And this is where we can write our script. We can close this also. You can close it and directly type your scripts here. So if you type it, it will come here. But instead of that, we can actually script our script here and then run it in the console here by using this particular. So I just there are some results here. I can go for opening a new file, but it will take time. So when you open a file, let us say, open a file, it will be a new R script like this. So, so I have a code here. So I will keep running this code here. So I'm just going to run a separate code. So I just explained the process. You don't have to worry basically. So R is basically programming based thing. So first what I'm doing is I'm just bringing the data. Anything which is typed in the hash, this is basically information. Text is like a node function. So anything without this is taken as a I think now will be visible, right? Yeah. So this I'm calling this particular data called air passengers. I'm just keeping the cursor here and just running this, and you will get the data called air passengers data. Okay. So there is a data called air passengers just added. So what I'm going to do is like I'm just going to structure this particular database as a time series database and plot this particular data as a time series data because what this air passenger is all about is I'll just tell you air passenger information. Let us assume a particular aircraft is having a number of air passengers particular it is operating in a particular number of years. So let us say this is from 1949 to 1960 and airbase company is having this data. What it does is like we are taking that particular data and saying the monthly data starting from 1949. So any real-time data can also be used. What I am doing is I am just running it and it has set the data, normal data into a form which is basically understand 1949 January to until 1960 January. So every month there are different values. 1949 started at 112 January. That way. Look at 1960, obviously the business got grown from 17 to 32. So there are a lot of ups and downs in this particular time period. 1 month there is an increase, 1 month there is an increase like that. Now I'm just plotting this particular time series graph and it looks like this. What we can infer from this, like over a period of time, the business has grown to a great extent. there are a lot of ups and downs within that particular period, which we need to capture it so that you can actually predict. So our prediction year at the is 1960. So we are 2024. That is 1961 as our prediction year. So with the past data, how we are going to find out this 1964, sorry, 61's, monthly projection of the air passengers. So obviously a company like a flight company will be able to be prepared for the air passenger because in Indian context, not all aircraft are owned by they take it in these actually. So if they find out that in a particular month there is a huge expected passengers coming in, obviously they'll give you a contract month in advance so that they can negotiate and they can give the prices. For all business decisions, we need forecasting. How much staff you need, because sometimes leasing of aircraft comes from people who are with the people, sometimes without the people. So there are different kinds of leasing involved in that. So for all operational requirements, for example, working capital requirements, you need to during that particular month to find out spike in your air passengers. So for all these reasons, you need to forecast. So I don't have to explain why we need forecasting. So I just explained how this is being done. So we have got it. But what happens is like there are certain aspects involved in this particular graph, wherein each there are ups and downs and things like that. With this huge ups and downs, we cannot actually predict with accuracy. So for that particular reason, what I do, technically it is called as non-stationary. So in a time series when you have stable movement of information, okay, let us assume it goes like this without any much mistake. It is easy to understand. But here there is a lot of ups and downs like this, and it is the ups and downs if you say it actually increases at an incremental rate. Now the time series become very complex to be modeled for prediction purpose. So what I do, I am just making, this is a basic thing for me. I do log conversion of this particular thing in order to make the time series stationary. Okay. So now if I plot that particular the log conversion, I have written a capital letter, small letter is basically. So log conversion, plot. If I read, you can find out a different graph. The previous one was incremental. Now it is more stable and it is looks more stationary than the previous one. So you can understand the difference. The previous graph is incremental. The log converted to graphic is like this. So it is more stationary. The previous one was more incremental. So stationarity is one essential aspect of time series forecast. I hope you remember from where we have started. We have started with analytics and then we have moved on to types of analytics and we have focused on how methods of predictive analytics, what is predictive analytics, methods of predictive analytics. And we have understood that there are two ways of your doing it, one is statistics and one is machine learning, and there are some Asian methods also, right? As well as movement-based methods. So basic difference between statistics and machine learning is interpretability and large usage of large amount of data, large data, big data. So in order to understand what ML, we have understood the ML architecture, basic ML architecture, the name of neural network, called as artificial neural network, which deals with numeric data. And then we have moved on from numeric to ANN to RNN, CNN as a concept where it takes non-numeric unstructured data. So anything that can be done with the ML model, that is the basic understanding. So from there we have moved to what was the application of predictive analytics in commerce. Then we have started to use AI terminology, AI also predictive AI. Both are more or less same. These are different layers of the same concept. So in predictive AI analytics, there are different applications like e-commerce applications where how PepsiCo uses it for marketing purposes. So from there we have moved on to how this primarily applied in the context of finance. So what you can understand is like robot advisory and fraud detection. And you have chatbots. You open a bank, there will be an automatic discussion. All these are basically able methods. One not text data, one not numeric data like that. So similarly, from there we have taken one use case called algorithm trading. So algorithm trading is a very advanced topic where it requires a lot of algorithms taking the cognitive aspects of algorithm. But if you narrow down the very fundamental aspects of this algorithm trading, is like you are dealing with the stock price data. Okay. So instead of taking the stock price data, what I am doing is like in order to understand the broader revenue, I am taking the commercial information. So the same air passengers can be considered as stock price, monthly stock price. So the stock price of ICICI was 112, 128, 122 like that. So that you can easily understand the particular adaptability of the data. So both are time series data, sales data, and things. So if it is a stock data, also we are going to do the same process. The methodology is going to be the same. So a bit we are going to start to a broader dimension of commerce services. So we have an air passenger data and what we can do with this particular data. So we have found out like the data is non-stationary. So when there is a lot of fluctuation, you cannot predict like somebody behaves or very highly fluctuated behavior, you cannot be a friend with a particular person, or you cannot be in a relation with a particular person because you cannot predict them. So the same applies to data also. So data is basically if you are a lot of randomness is involved, then it is called as non-stationary. Data should be stationary or should be made stationary in order to predict them. So we have made a basic stationary transformation called log transformation or log transformation. So when we have plotted, we have found out like the data more stationary than the previous information. Now we are coming to the most important aspect. When I was discussing about this information, this data, I have mentioned like a lot of ups and downs are there. So any time series data will have behavior like this. There will be down and up. It cannot be a straight line. Then you don't have to predict it. Like this, you the same straight line. So here there are a lot of ups and downs. You want to find out the next time is up or down so that you can make that decision. So for that, we need to break down this time series data, which is what we call decomposition of time. So there's a code here. This is the theoretical aspect. Decomposition breaks the data into different parts, and if you decompose, you will get a graph like this, which is helpful for us to understand the behavior of the entire thing. So when you decompose the time series data, this is the observed information. We have that log transform that information. Then the software has broken that information into a clean trend. So this is the trend. We have some how it emerged 5.5, 6 like that. So this cannot be interpretable right now because we have done the log transformation. In case if it is the actual data, we will get the air passenger value here 400, 200, 300, 400. So we cannot interpret it because we have done the log transformation. Without this log transformation also, you can decompose and see the data. So we are trying to model this data. We have log transformed. It's how it appears. It has found out like this much of seasonality is found in this particular and randomness. So this much of randomness is there. The data looks like there's a lot of randomness involved. But the beautiful part is like it has captured all this information. From the observed the data is filtered, the seasonality is filtered, the trend is filtered, the randomness. Now it will be able to find out like without the season, without the randomness, by taking the seasonality, by taking the what you call the trend, how to predict this particular. Okay. Now there are models available for this. This is a traditional statistical classic statistical model called INO model, R model. So this is basically automated in R. So what I am going to do is like I am going to build a model like this very quickly. So this 3 steps will take a model because a very tedious process from this software. But today with GUI based software like GUI and other particular process keep the tab and this like that. But here the tools will be very easy. So for model creation, what I do is like there's a library required for it. So R is a basic platform. If you are doing it for finance purpose, you need a particular library. If you do it for marketing purpose, you require a particular library. The use case again. Now what I am doing is I am going to create a model. Okay. So I'm going to plot this particular model, and this we keep doing it now to show you how the process happens. So I'm just selecting it and running it. So library will get updated, and the library will get the red symbol like this. And then we have created a model in the name of model action. We have created a auto function. Using that, this air passengers not transform the air passengers by splitting the trend, seasonality, and randomness. We have created a model. So we have created the model aspects. So with this created model, we are going to forecast this particular behavior of life. So let us say what I am going to do is like there is a forecast library which is called as ggplot2. You are own interface which is called the usual process. So what I am going to do is like I am going to make a file name here by using the function forecast. What I am going to forecast is like I have created a model for air passengers using authority. So this model I am going to forecast. And how many months I am going to forecast? I am going to forecast 48. For example, I can say what happens the next year. 12 data points that I'm going to forecast. So I'm just running it. F is created actually. If I plot F, then you can easily find out that this is what is F is all about. So this is the observed information and this is the forecast information. Now, what will happen to the air passengers in the coming month, coming year, 1961? For 12 months, we have predicted. If you give 24, it will give for 2 years, it will give 26 for 3 years. But as the nature of time series, most of the prediction is better accuracy. So now, visually, we have understood we want to know like how this basically that how we interpret this value basically, because our values are okay. So there are some accuracy measures available so that you can find out like so lesser the error, higher the accuracy. Now this is a function like I have created a file here. I wanted to see the file, tail of this file here, like this, and it is giving me this kind of information. Okay, so it looks like, for example, this. So fitted information, and there's a lot of. So you can see here there's a dark blue line is there, light blue line, clear line, blue line. So these are all ranges basically. It will say like this much percentage of, for example, like 80% of this is the value, and 95% of confidence, this is the value. So we'll have some in between, which is called a fitted line. But again, we cannot interpret this 4.715. It's a log value. We want to know like what will happen to the 1961 data. 1961 year, what will happen to 12 month value? So for that, we are just converting that into this value here. Just check. Okay. Now what it says is like the same 1961 value has calculated like this. It says like with the available 1949 to 1960 information, it has created a model like 1950, which will be in January 1949 for 25 years. 479, 492. Likewise, each month it has given a projected average. So obviously, people can take this particular information in order to be prepared for discuss this situation. Again, we have not given emphasis much on the error part and how to print the model. Maybe without log transfer, with some other transformation, better than log transformation, we have given more precise, more accurate prediction with lesser error values. So that is also possible. Those are data science. So as a researcher, if you want to build a model in such a way that you predict the sales, you want to find out the sales dimension of a particular as the chief justice said, case study methods are available. If you want to take a particular case of a particular company and you want to predict like what will happen next, and then suggest some measures for that particular company. So this is a traditional statistical model applied on a time series data. I repeat, time series data in number of orders that you have got in Zomato or things like that. So it can be any number, and if these are set on a time basis, we call it as time series, and we try to apply the same model for application. So this is how it works for time series based predictive analytics. This thing. ML, again the same process is available, but I just show you the hello. So this is a kind of data that is available, and try to find out like risk model. For example, if a loan application is given, you want to find out the probability of that particular application getting accepted or rejected. So when the probability is higher, obviously I will start to process that particular application. The probability is lower, obviously I will be rejecting the application on the less risk. This we would have encountered in most of the cases where, for example, automobiles, if you go for a two-wheeler, where you some person sitting from the back and they'll have a tab and they'll give some payment information. They'll find out like, oh, our bank will not give you loan, or they'll say like, your EMI will be this much. Maybe the other bank will say your EMI will be lower. The other bank will say your interest rate is higher. So likewise, they'll have their own models and they'll apply that particular model in their software. In the back end, this is what usually happens. So I just run this code of neural network alone because neural network is as similar to the time series model we have built. So there is a function called neural network. So with the credit data, I just explained the context indicators because we want to perform this analysis. So there is a data information which is like old EMI, years of address, down payment. So with I have given some 20 factors like this to create a credit risk model. And the neural network has found out like only these models are very impactful. To my concept literature understanding, I have found out that these models are impacting the credit risk of applicants in my bank data. So I have chosen this thing and they are following how much is the loan amount that is. So I was telling about different examples. The loan application is accepted or rejected. That's a binary thing where it looks like a logistic equation. Here it is a kind of linear equation here, which is applied on artificial neural network. Now it has found out and said like this is the loan amount you can find. Now it is not interpretable as similar to a linear equation where y is only plus 0.6 of x. So for example, 0.4 of old EMI, 0.2 of years in address, 0.6 of down. How much down will he asking for? Minus 0.2 of down payment he is making. Likewise, you will get an impact. Here you will not be able to get that. What it says is like if you feed this information, this loan amount projector, it will be given. So this is the advantage of linear equation. That is the advantage of linear equation, and the predictive power is the advantage of artificial neural network. So these are methodologies, and R is a platform you can explore such methodologies. I think broadly I have covered what I have intended for process. Instead of going with slides, actually I have complete R and then I have to do the process basically. I will share some of the information with you so that we can use it for further discussion or research purposes. So if you have any questions with respect to our discussion, I'm ready to take it. We have 5 minutes to get this time.
Any participant, if they have any queries, they can post to the chat box. I can read out the question to the answers person. If be a questions in the chat box. If there are no queries, we can conclude the session with a word of thanks. I'm not considering any of the questions. Okay, thinking that the session was more informative and it's very clear to all the participants. There are no questions. I think we can further proceed with the word of thanks and conclude the technical session 1 for today. And after that, I'll be posting a feedback link. I request all the participants to stay back in the meet for a while. Now I request Samina Hanuman to present vote of thanks for our resource person.
When you're muted.
Yes, sir.
It's a privilege to propose a vote of thanks. I take this opportunity to thank our chief guest and today's resource person, Dr. Riaz Ahmad, for giving such an informative session. Sir, thank you very much. We had a wonderful session. Thank you, sir. I also thank our principal, Devika Madam, for your presence. Thank you, Madam. I thank Professor Satyanarayan, sir, Dean, Department of Commerce and Management. Thank you so much, sir. I also thank Dr. Jyoti A.N., Head of the Department, Commerce and Management. Thank you very much, Madam. I also thank all the participants for being so attentive in the entire session. Thank you one and all present here. I take this opportunity to thank faculty members, technical team. Thank you very much. Thank you one and all. Thank you so much.
Thank you so much for the opportunity.
We have to discuss this. So would you like to express any of your opinion regarding the technical session 1?
Thank you, Professor Riaz Ahmad. We had a very good opportunity to listen to you. You have presented us very good information and in advanced way and a decent way of research and methodology and covered the subjects that concerned. And I personally thank you, and I feel our partner of the and personally either in our campus or in your campus. Thank you so much.
Thank you. Thank you all for the patient listening and thanks for the calling for inviting me for the session. So thank you.
Once again, thank you, sir.
Thank you. So we can leave the link.
Sure, sir. So regarding the tomorrow technical session 2, so the schedule has been like half an hour it has been preponed due to the availability of non-availability of the resource person. So the tomorrow's technical session 2 starts at 10 o'clock sharply. So I'll be posting the link in the group by 11 o'clock. So I request all the participants to be active by 9:45. So it will be from 10 to 11:30 technical session 1, 11:30 to 12:30 will be the technical session 2. So tomorrow we're gonna have the 2 technical sessions. Technical session 2 and 3 we're gonna have it tomorrow. The link will be same. The link is at 10 o'clock, it completes at 12:30. So tomorrow there won't be any of the state of the navigation programs. There won't be any delay in the technical sessions. So immediately we start the technical session. That's from 10 o'clock to 12:30. It's included 2 technical sessions. And kindly I'll be posting the feedback in the chat box. It won't be posted in the WhatsApp group. Kindly who are participating now at present participants are there. Kindly give the feedback. Thank you.
One more information.
Yes, sir.
Suppose for some personal reasons, if any participants were not able to attend this today's technical sessions, they can also attend tomorrow. And they will be specially considered for certificates also. So that can be communicated to your friends. I think that will be okay. I believe my technical and coordinators, staff coordinators will also answer.
Sure, sir, we'll do it. So now as today's session can attend to tomorrow's technical session. Even then the feedback will be considered for the certification. Thank you everyone. So the meet will be active for another 10 minutes. So you can just copy the feedback link and fill it up. Thank you everyone.
ಇದೆಲ್ಲ ಆಫ್ ಮಾಡ್ಸಮ್ಮ ಅದೆಲ್ಲ ಆಫ್ ಮಾಡ್ಬೇಕು ಒಳಗಡೆ ಇದೊಂದ ಇಟ್ಕೊಳ್ಳೋ ಒಳಗಡೆ